Welcome to another video. In this video, we're just going to be using the sum formula to calculate the sum of the numbers or terms in a geometric series. Okay, so we just need to get started. We have three formulas that we can pick from. It just depends on the question that they're asking. However, the first one and the second one, they are pretty much the same formula. You can just pick whichever one you like between those two. With the third one, you only use it if you are required to calculate the sum of all the terms up to infinity. So we have a question here. We are given 2 plus 6 plus 18 plus 54. When you look at it, that is a series. It's actually a geometric series. So we can use either one of the three formulas given, depending on what the question is requiring us to do. Okay, let's look at the question and pick a formula. First question. Determine the sum of the first 10 terms. Because they are telling us how many terms, we have to pick either equation 1 or equation 2. If it was to infinity, we would use equation number 3. So in this example, I will pick equation 1. Okay, Sn equals to a r exponent n minus 1 all divided by r minus 1. They told us to calculate the sum of the first 10 terms. Therefore, n is 10. Sum of the first 10 terms equals to, remember a is always equals to the first term. The first term is 2 in this case. What is r? R is the common ratio. 6 divided by 2 gives you the r, which is equals to 3. And then the exponent, sorry for that, it's still 10 minus 1 all divided by 3 minus 1. And then you just punch that on the calculator. You should be getting a value of what is the value? 59048. Then you're done with that. That's how you can apply the equation. Another way in which you could apply the equation is in question 2. They are saying determine the value of n for which the sum of the first n terms is 242. So they gave you the sum of the first n terms. Now they're just asking you to determine what n that is. Basically, it's similar to the first question. We're just now working in reverse. So we still have the same formula that we have used, r exponent n minus 1 divided by r minus 1. Just make sure that the brackets look the same. If we use circular brackets, let's use circular brackets. So the value of Sn is 242. What is a? It's still 2 because we're still using the same series. R is still 3 for the same reason. N is what we are looking for in this case. And then R is still 3 minus 1. So now we're just going to simplify this and then see how much we get. We still have 2. I'm just going to firstly simplify the denominator and make it 2 like that. That makes it clear that the 2 will cancel with the other 2. Then we are left 242 equals to 3 exponent n minus 1. We move the 1 to the left hand side. We are having 243 on the left hand side, and then we are left with 3 exponent n on the right hand side. Those who use the Casio calculator can know how to write this in exponential form, 243 in exponential form. So how you would usually do that, for those who might not know, you just need to type 243 equal sign shift fact. It gives you that 243 can actually be written as 3 exponent 5, which is equals to 3 exponent n. Therefore n equals to 5. Because of equal basis, they mean the exponents are also being equal. Then you are done. That's one way in which you could apply this equation. And if maybe they were asking you to get the sum to infinity, not sum of the first or anything like that, they're just asking you to get the sum to infinity, what you will do is to use the last equation. Sum to infinity equals to a over 1 minus r, and then you know your a is 2, 1 minus 3, that is 2 divided by 1 minus 3 is negative 2. And then what is your sum to infinity? It's negative 1. Then you are done. that's basically how you could apply either one of the three equations. Even though here I chose equation 1 for number 1 and 2, you could have just used equation 2 and did this question and you would have arrived at the same answers. Thank you for watching. I'll see you in another video. That's all that I wanted to show you in this video.